So remember we had properties if it was like C times K, or if it was just K, or if it was K squared. For all of these, this is the only thing that could be in it.
Oh.
So like if this was N squared, that would work.
Okay.
Right? This has to match whatever variable is down here. Right? That's the only thing the property works for. So in this case, we can't directly use that one, right? So did you two get it? You know how to do these? Okay. So anytime you see something like this, it's always the same pattern. It's very easy. Okay. So the first thing you do is you want to expand this. You always want to expand whatever is in here because we want to get rid of all parentheses. So we have 9 minus 6n plus n squared. What can we do after? You guys had something like this we did together in class, right? So does anyone remember? Yeah. We already came from this step to this step.
Oh.
So let's look at the properties that you guys had. You all wrote down some properties, right? Yeah, this is exactly like one of the examples that we did. So try to find what one that was.
Oh.
Yeah.
Wait, do you separate them?
How?
Like, what is this symbol called?
Sigma.
Sigma? Like sigma 9 minus sigma 6n.
Good. Yeah. So the next step is to separate these, right? So no, I think, all right, try it on your own. I think everyone has found out what to do. Shout out to you, Anish. You got everything.
He's just complaining in the oven.
Anish is the MVP, dude. You got the Hostess cupcakes.
I got you.
Some Three Musketeers. Take 5. Yeah, if you guys want any, just go get it. All right. I'm just gonna put it in the back. Good Anish. Yeah, keep going. Yeah. Good.
Don't you use like the linear like property, like for just like reading?
Which?
For sigma 9.
Okay, so guys, what do we do about this first one right here? So if I just gave you this, right? Well, what does this equal to? It equals to 9 times 8. How come? What's the difference between this one and remember we had a property that was like at least k. That was like this, right?
Oh, so
what's the difference?
How
come we don't use this property for this?
Because there's no like k, like
There's no k here,
yeah.
right? K in this case is always this variable. So if you had an n here, that would be okay. But remember this, we can move the 9 to the outside, right?
Mm-hmm.
And then what's in here? Well, whatever's left over is just 1, right?
I'm getting 66.
And so, did everyone get to this step? I think that was pretty good for you guys. And then we just use the properties. Don't do everything in your head, though. Yeah, so and then minus.
How would you do this?
Right, so let's look at the properties. So which one of these can you use? Yep.
I'm getting 66 now.
Well, then you did all this in your head?
Oh, I guess. Wait. 36. It's 36. Oh, so 30 hours.
That it is 60. So don't do all this in your head, man.
Yep, 60.
Did you get the answer?
Well, I mean, like, not this
You
one.
got the same expression?
Yeah.
Okay. Yes. So the answer is 60.
Yeah.
If you multiply. So right, so that's good, except you forgot one thing, right? You move the 6 out in front, so that's your coefficient. So you can't forget about the 6. No, you don't have to erase it. All you gotta do is add 6 times that, right? Because this is just equal to the right side, sigma n. So you just gotta multiply that by 6 again, okay? Yep, so the moral of the story is anytime you see something like this, right, we have no property that can help us if this whole thing is squared, right? So always just expand it, and then it's the same thing. There are only 3 properties that we know, right? So all you got to do is just use them, and then it's the same thing every single time. Okay, for these, there's not much creativity in the problems, right? Cool. So for number 2, how did you guys do?
I did.
So this is a hard problem, right? I just wanted you guys to like sort of think about it. So let's just start from the beginning, right? How do we approach this thing? We need an asteroid and then vowels in alphabetical order.
But like, can't you only put the vowels in alphabetical order in one way?
Yep, exactly. That's the first thing that's, I guess, a little hard to notice right off the bat, right? Alphabetical order, the vowels, there's only one way to do that, right? So that's like the first trick, good. So what's next then? So that's what, A, E, I, O. Not that it really matters, but. So how many letters do we have left over? We have 4 more letters, right?
So
So
those 4 are just like what you're out of, because the rest are fixed in place.
the rest are fixed in place, but where can we put the consonants?
Anywhere. Well, I mean, like there, you can do it anyway.
Mm-hmm. So let's do this, right? Total. Whenever you do these like arrangement problems, it's helpful to like draw out like the spaces. It helps you think about it. So you guys understand there's only one way to arrange the vowels, right? Okay. So our first step then is what? To pick where the vowels are, right? Or we could ask the same question. We're going to pick where the consonants are. It's the same thing, right? So how do we do that? How many ways can we pick where the vowels go?
Just one. Like A would be the first.
But so we have 8 slots, right? Because there are 8 letters. So we could do A, E, I, O right here. Or we could do A, E, I, O, or A, E, I, O. So those are all in alphabetical order, right?
Yeah.
So how many ways can I pick where the vowels go?
1.
O can only be from the 4th spot onward.
That's true, right? So what? So that's true, right? But let's just totally ignore the consonants right now, okay? Let's just worry about the vowels. So this has to be the order it's in. That's a big help. But now I want to know where we're going to put these. So if we have 8 slots and we have 4 letters, how many ways can we arrange the vowels?
8C4.
8C4, right? Out of these 8 spots, we're going to choose 4 of them. And then whichever 4 we choose, it has to be in this order, right? So you guys understand that part, right? So 8C4. So now we got 4 more spots, right? So all I'm going to do is we're just going to erase that. We have 4 spots left for the consonants, right? Does it matter to us where these spots are relative to the vowels? Does it really matter? No, right? We could have all the consonants before all the vowels, or after all the vowels, or in between. It doesn't really matter to us, right? What does matter, though? The order of these consonants, right? Because out of these 8 spots, we already chose 4 for the vowels. So let's say we chose this one, and then these 2. These are the vowels. So now we have fixed spots where the consonants can go. But then we have 4 consonants left over. How many ways can we arrange those consonants in these 4 spots?
4 factorial.
4 factorial, right? We got 4 letters, and I just say we have 4 spots for them. How many ways can we move them around? So that's 4 factorial, which is the same thing as 4p4, right? So if we multiply these together, this is all the ways we can arrange, given that it's asteroid vowels in alphabetical order. For each arrangement of the vowels, we have 4 factorial ways to arrange the consonants. So we multiply those together. You guys understand this? Kristen, William, you guys understand? This is something that's, very difficult. So don't, be too worried if you can't get this on your own. But like, I just want you to understand it now. So like, do you understand it now? If you're good, then I'm happy with that. Awesome. Okay, so number three is a tough one also. So 4-digit numbers formed from 7, 3, 3, 2, 2. We're given that it's odd, and we want the probability that the 3's are together. So we want a probability. So that's going to be some fraction, right? What's on bottom of our fraction?
The like amount of numbers.
No, not just numbers. We're given something, right? We're given that the number is odd. So on the bottom is going to be the total number of odd 4-digit numbers, right? We're given that it's 4 digits. We're given that it's odd. So what's on top? William, what's on top on a numerator?
Number of odd 4-digit numbers that has 3's.
That have 3's together, right? So it's the same thing with 3's together. All right, so can you guys think, you guys can all like just talk out loud, work together. How can we get this bottom first? Odd 4-digit numbers. How many ways can we do that?
Aren't there only 2 odd numbers like in
Right, yeah.
So,
Yeah.
But we have 2 3's and 1 7. So just try to figure that out. Take like a minute or two.
Just 1 over 1. 1 over 3p. 3p
3p3. Yeah.
divided by
2 by.
factorial.
So William
No.
says it's 3p3 over 2 factorial. Why?
Or no, like it's 1 over that. 1 over 3p. We'll just keep
Like put the
over
3's together, it would be 1 over 3p3 over 2 factors.
Why?
No, that's weird.
It works. It works. Come on.
How do we get this? The number of odd 4-digit numbers.
3p3.
Repeat.
Why?
Well, you
Because
doesn't work.
why?
Well, since that's
Why is it
the
6?
whole number. That's the probability.
3p3 is 6, right? So how come we have 6 odd 4-digit numbers? How did you get that? No, how did you get that?
I mean, like, there are 3 digits, and your order matters, right? So,
Yeah, but that's only you only get that amount
Yeah,
of number.
yeah.
Like the first digit.
Okay, so 4-digit odd numbers. We have 2 possibilities, right? So how many ways can we fill out these 3 slots? How many ways can we fill out these 3 slots?
3 factorial times 3 factorial.
For this? How come?
Because there are 3 spots.
Right, well, we got 4 numbers.
6
We have 4
ways.
numbers, 3 spots, and then this is the troublesome part, right?
6
We have 2 3's and 2 2's for this, so.
6 ways to total part there is.
No, but if you have 2 3's and 2 2's, you can eliminate like them from the order because they'll be grouped together.
You can, what do you mean?
Like you don't need to. You only need to count in 1 3 and 1 2 because like they're the same number, right?
Okay.
So doesn't that give you like 3 numbers? 3, 2, and 7.
Well, okay, so just list it out. We'll do it the baby way. Let's list out all the ways we can do this. Yeah?
Okay.
3, 3, 2.
So let's just go from lowest to highest, right? So we have 2, 2, 3. Now what's next?
2, 3, 2,
Sure.
2, 3, 2.
32,
2.
and then
32, 32, 3,
and then 3, 2, 3,
32.
3, 3, 2. That's it, right?
That's 6.
There's no other way we can do it, right?
No.
Okay, so that's 6. How about this? Then we have 2, 2, and 7, and 3 left for here, right?
You just do the same thing, but then you just add in like the 7s, right? Like after.
So list it. Just list it.
Okay.
List it on your own.
2, 2, 3, 2, 3,
Okay,
2.
yeah. All right. So say it.
2, 2, 3. 2, 3, 2.
Oh, so you're saying you're gonna say all of these,
Yeah, it would be all of those, and then you would.
and
add
then
the
plus.
We can't. Oh yeah, wait. No, you can't do all of this.
Why not?
Just 2, 3.
Because there are 2 3s here, 2 3s there.
Just the first 4.
So we can get 2 2 3, 2 3 2, and 3 2 2. Is that it?
That's it.
That we can use over from here.
Yeah, yeah.
All right.
Yeah.
So what
So
else?
then it would be like 2, 2, 7.
Okay.
Just 2,
2, 2, 7, 2, 3, 7.
Is there a better way we can list these out?
How do you convert like a factorial into a permutation?
Well, that's the formula.
Okay.
Kristen, you've been pretty quiet. You have any ideas?
No.
You're working hard on something.
or I'm getting 32 possibilities, so I'm not sure if I'm doing it right.
You're getting 32.
I'm doing 32 possibilities, just seeing what I'm in my head, because I'm not sure if I'm doing it right.
So you're saying you listed out 32 possibilities in your head.
No. I'm just like randomly thinking, like, plugging in there, and just hope it'll be right.
Okay, so let's try to look at this, right?
Right.
For this possibility here, we have 4 numbers. We had 3, 3, 2, and 2. Okay. We have 3 spots, and then we have 2 repeats. Is there a way we can try to mathematically, do something, write some type of expression to get the answer 6? Because we listed out, we know the answer is 6, but we have 4 numbers. 2 of them are repeats, and then 3 spots. So
can't you do like, 3 factorial over 3 minus 2 factorial?
So you're saying 3p2?
No, because that wouldn't be 6.
So let's maybe start with 4p3. Why 4p3?
Because you have 4 digits, and
And we want to pick 3 of them, right?
yeah,
All right, and then what? So what does 4p3 equal to?
4.
4?
Yeah.
how do you know without doing like the calculating?
Well, just look at this. 4p3 is equal to what?
24.
Right, 4 factorial over 1 factorial, which is 24, right?
Oh.
So what? Now what?
That's something wrong.
But now what?
You get 24.
4p3 is 24, like Kristen said, right? But we know we have 6 here.
So 24 over 4.
How come?
24 over 4 is
Factorial times 2 factorial.
Right, over 2 factorial times 2 factorial. How come?
Because there's two redeeming numbers.
Right, because they're 2 3s and they're 2 2s.
Okay.
So this works, right?
So this 4, 3, and.
So if we try to do the same thing for the next one, what would it be? Because we have, what is it? 2, 2, 7, and 3, right? So we could do 4p3 over 2 factorial, so they're 12, right? So how many total ways for the bottom?
4p3 over 2 factorial.
Well, it's just 6 plus 12,
Oh, okay, yeah.
right?
Yeah.
So bottom. Do you guys agree so far? So how about the top?
Wait, you just like added the 2 permutations, right?
Well, yeah, because we had 6 possibilities where 7 is the last digit, and we had 12 where 3 is the last digit.
How those 2 possibilities are using because at the bottom there is.
And then like the top would be like some factorial, right? Because the 3's are repeated.
Wait,
How many of the 18 possibilities were there like repeating 3's?
That should be easy for you to answer. The top should be easier for you to get. Out of the first 6, how many do work?
2.
2. And now your job is to figure out for the bottom how many.
So 2 over 6 equals x over 18.
This is 5.
Okay, so this, there are 2, right? And we're going to add something.
6.
For this, we know 3 is the last digit,
So 3 has to be.
right?
Mm-hmm.
So basically, you're asking how many ways can we do this? And then what is here? 2, 2, and 7. So how many ways are there to do that?
3.
Say it in permutation.
Oh, okay. 3p4 or 2.
3p2,
Yeah,
right?
yeah.
Over
Over
2 factorial. So what's that going to be? 3p2 is what?
3p2, 3 factorial.
Over
so,
1 factorial.
Yeah, so 6 over 3, 2.
So 6 over, this is 6 over 2, which is 3.
Yeah.
That's our answer. Kristen, did you follow along? You were like writing some stuff.
Wait, how'd you get the 3p?
This one right here. So so what we did was we said there are 2 ways for this where it's ending with 7 to have the 3's next to each other, and we know that because we listed all of them out, right? Because that was easy to list. For this, we said, well, if the 3's are touching, since we know 3 is already the last digit, we're basically asking how many ways can we do this, right? Because this is the only way the 3's can touch if 3 is already last. So then that means we have 3 leftover numbers, 2, 2, and 7, and we just have to fit them into here, right? So then just 3 of these, choose 2, and then since they're 2 repeats, divide by 2. Okay? Well, 5 over 18. William, you look mad.
Sure.
You okay with this?
Yeah.
Does this make sense to you? Yeah? So if you get, you're not going to get something this difficult, but do you see the reasoning behind it? And do you see how we use the permutations and stuff? The concepts are important. Okay, if you understand the concepts now, then when you get easier problems, you're going to get them easier. Does this make sense to you? Yeah? Okay. Because Lucille didn't know. Now, if I told one of you guys to teach this to Lucille, would you guys be able to?
Possibly.
Yeah, sure.
Possibly. Good. Alrighty. Did anyone have any questions about anything before we start the next lesson?
What is the next one?
We're just finishing up series and sequences.
Oh.
That's a good question.
How long is the next lesson going to take?
Today's last class.
Okay.
It's not hard, is it?
This is just a long.
That's subjectives.
I don't want it to be hard.
Is it
It's not terrible, but it's not easy. It's new.
I like easy stuff.
Some people like this could get a little difficult for some, but it's not awful.
We're in
Okay.
geometry right after this.
Wait,
Why
I
is
don't-
geometry hard?
did everyone
No, I
take
mean,
this
like, I
physics
don't-
lab after this? Since I don't.
No, right after. Right after is geometry with Dennis.
Lab.
I didn't hear anything about that.
Lab. But you said there might be physics lab. But we never.
Alrighty.
Wait, when's that door coming back?
I don't know. Okay.
When's that one coming back?
6, 9. All right. So the first thing we're going to do today is talk about arithmetic sequences.
Oh. I know this. Sorry.
Okay. What is an arithmetic sequence, Anish?
You shouldn't put me on the spot. It's like, isn't that what we've been doing? It's just adding, right?
So we learn what sequences are, right? It's just like some pattern of numbers. Like we'll say 2, 4, 6, 8. This was the example I used the other day, right? But then I also gave one other example here. 2, 4, 8, 16. Like that, right? So, and then we found the explicit formulas for these two, right? You guys remember? You guys said this was that, and this one was this, right? So we can tell very easily by looking at the first one that we're just adding 2 every single time, right? 2 plus 2 is then 4, we add another 2, that's 6, and so on, right? So this is what we call an arithmetic sequence. The second one was different, right? The first one, if you just add the same number to every single term, that is an arithmetic sequence. Okay? The number that we add every single time is what we call the common difference. So usually we use the letter D for that. So in here, we can say D equals 2. The common difference is 2. So let's say we have an arithmetic sequence with some common difference D. I'm not going to tell you what it is. It's just the variable D. What is the recursive formula or the implicit formula for this sequence?
A D minus 1.
So A what?
A.
So A sub n equals.
Yeah. Okay.
Right. So this means the nth term
Mhm.
equals what?
A parentheses D minus 1.
A times D minus 1. Is that what you mean?
Yeah. Because like for this one,
No.
A D minus 1. Wait, no. A.
So the nth term is equal to, and then we're going to put it in terms of the previous term, which is the a n minus 1 term,
oh, okay.
right? Plus D. This is always going to be the recursive formula, right?
Oh.
The nth term is just the previous term, the n minus 1 term, and then you just add that common difference.
So
Right.
D and N aren't like interchangeable.
D is always the common difference. N is which term you are on, the first term, the second term, and so on, right? So, for example, if n equals to 2, second term is equal to n minus 1, that's the first term, right? 2 minus 1, the first term plus D,
Okay.
right? Pretty easy. Second term equals to the first term plus the common difference. Yep. So, now we can get also an explicit formula for this, all right? This is going to be equal that. It's equal to the first term, a sub 1, and then plus D, the difference, times n minus 1. This you definitely should write down. The first, this recursive one, you guys can figure that out easily. The second one, write that down. You're going to be using it a lot. Okay, and does the second one make sense to you? If we have n terms total, right, and we want to find the nth term, then if we know what the first term is, how many times do we have to add the common difference? You just add it n minus 1 times, right? So, for example, if we want the fifth term here, fifth term, and we know what the first term is, how many times are we going to add the common difference? Well, we look here, right? We add it once there, once there, once there, once there. So if we're at the fifth term, we're only going to add the difference 4 times. So that's why this is n minus 1. Okay? And that's how many times we add d to the first term. Okay? One more just real quick thing. Later on, you guys are going to get a bunch of like sequences, and then it's your job to figure out what kind of sequence it is. And so if it's arithmetic sequence, just always try to subtract, right, to see if there's a common difference. This is always the first thing you want to check, because arithmetic sequences are easy, right? Just subtract all the numbers to see if they have the same difference or not.
What have like what do you do not want this?
I'm not even,
Then why would you try to place a word that's like several like 100 digits down?
Okay.
It's even below.
all right, so find 10th term. So there are a couple ways to do this. All right, we'll go over the different ways later, but just figure it out any way you can right now. And I'm telling you that this is arithmetic. I have to tell you that, otherwise there wouldn't be enough information.
I have a question for like the explicit formula.
Yes.
Can this does this always have to be the first term?
What do you think?
No.
Oh, then we got it wrong. Yeah, at least he finished it.
Oh,
Yep, so that works. Okay. Now figure out what n is.
okay. I'm just
Do you know how to do this? Okay. Ooh. No, not for one.
yeah. I can add. I can't add. No. Okay.
Well, let's do a 1 more minute. Yeah. So, what you say? Yeah, how'd you do it from here? What's this?
Like A6, like there are 3 places in between the two. So
Sure.
then getting them to multiply and then like get that. No.
So over here, what you did was you said this is equal to what?
The third term. So
You said you're starting with this term here, right? With A3.
oh, so this is equal to the second term, right? Because n minus 1.
Okay, so let's just go over this, okay? So William, what did you do?
Since I just took the difference in like A3, A6, well, it's like,
Okay, and then what?
so I found the difference and that's D, then I used, so.
Okay, so
look at
yeah,
A1,
yeah. So what's the difference between A6 and A3? It's 21, right? How many terms are between them?
3,
3. So what's our common difference?
21 times.
Divided by 3.
Divided by 3.
21 divided by 3,
Okay.
right? So D equals to 7.
Oh man, I
So
really wrong too.
So you guys finish the problem, and then we'll talk about some other ways you can do it. So after you get D equals to 7, you guys should be able to do it. Good.
Wait, n is like the term number, right?
Yeah. Okay, so let's just say we have D here, okay? So the first thing you could do is if you wanted to plug everything into this, you could, right? So let's say we wanted to do that. So then we could say A3 is equal to A1 plus D n minus 1. And so -5 equals to A1 plus 7. And then since this is the third term, 3 minus 1. You could do this, get what A1 is equal to, all right? And then plug in A10 into the same formula. So you could use D to solve for the first term, and then use that to solve for any term you want. Okay. There's an easier way to do that, though. But do you guys understand how to do that? Yes? Once you get D, you can do that. Or, Anish, what you were kind of looking at is doing something like this. So what you wrote was -5 equals, wait. Actually, I don't think you were on that. So what we could say, right, is this. Equals, and instead of solving all the way back for what A1 is, can we just use this? And then, so how many times should we multiply or add D? If we're going to go from A6 to A10, how many times, right? 6 to 7, 7 to 8, 8 to 9, 9 to 10. That's 4. Or you could just do 10 minus 6, right? And then we know what D is. So we could directly, instead of solving for A1, we could just do that, right? So the moral of the story is you guys should not think of this as a formula just that you plug and chug, okay? Because no matter what term I give you, you can always redefine things. So you can say, we can pretend -5 is the first term. We could totally do that. If -5 is the first term, then what term is this? It's just the third term. And what this would be the 7th term, right? So you can renumber everything on your own, right? As long as you keep in mind what you need to solve, and as long as you have D, all right? And another way to think about what William did to get D equals to 7, what we could have done is this, right? And then we would have to add D 3 times. So you could actually just plug it in. It's the same thing William did, but now in formula format. Right? Okay.
Oh yeah, I did this instead of string.
Really?
Yeah.
Oh,
Because
right.
if you're trying to show so much work, it's like
What did you take in 7th grade?
it's already.
All right, but hey, but you guys good with this?
The algebra.
All right, we have a lot of stuff to talk about. So now, remember what a series is? What's a series?
Is that like
You just add everything up.
Yeah.
The same thing as a sequence, except you just add everything. So instead of an arithmetic sequence, if I said arithmetic series, what do you think that is? Well, that's just like 2 plus 4 plus 6 plus 8, so on, right? Does this look familiar to you? This kind of looks like our summation stuff, right? Kind of looks like something like that. Yeah? This is the same as that. So then now we have a formula, all right? Sum of the first nth terms of an arithmetic series, all right? And this is pretty easy to derive. I like to write it this way. Oops. Sorry. Where do we get this formula from? Someone please tell me. What's a very easy way for you to remember this formula? Someone tell me.
That's the no formula for training.
This is exactly the same as this here, right?
Yeah.
This formula is the same as what the second formula property that we learned for summations. Remember? The one with the little cute story about adding 1 to 100. This is the exact same thing. Right? First term plus the nth term, they multiply by n divided by 2.
So, has that teacher ever done that to anyone, like, actually?
I'm sure. I mean, it's a true story. Right?
They might.
All right, so here is the problem. So this is our series, 3 plus 12. Yeah, good. All right, and I want you to find S sub 25. This just means the sum of the 25th terms, the first 25th terms, right? I think I have a name.
If n is like the term number, then what is a? Isn't n the term number?
What is A?
A?
What's A sub n mean?
Constant?
No. Remember all our formulas so far. For example, we had something like this, right? What does A stand for? What's the difference between?
The number?
N is always which term we're on. A is the term itself.
The term, okay.
So this is the nth term, right? This is the first term. So an is the nth term, a1 is the first term. Okay.
This is stigma like this.
No, I want you to use this. It's the same thing. It's literally the same thing. Good. What'd you get? So, okay, so how do we do this? Kristen, what was the first step?
Find out what the convict
Yep.
is.
Yep, and we look at this formula, right? We've got to know what a sub n is. So, how'd you do that?
24 times 9 plus 3.
All right, so 24 times 9 plus 3. And that's just the formula we learned a second ago, right? First term plus the difference, which is 9, and then times n minus 1. Yeah? an equals to a1 plus d n minus 1. So Kristen did that, and then she got, what did you?
219.
219. All right, William, you see how to do this?
Yeah.
Yeah? And then after that, you just plug it in here, right? So the first term is 3. So 3 plus 219. And then multiplied by what? 25 over 2. Good. And that's get you the answer, which is 2775. Yeah? You guys good with this? Okay. And just the important thing for this is to remember for these arithmetic series, this is the exact same as a summation, right? So William asked me, instead of doing this, could he just use the summation formula? Fundamentally, it's the same thing.
Yeah.
They come from the exact same thing. Okay. All right, so you guys understand this? No questions? All right. All right, after this, we're going to take a quick break. So we talked about what an arithmetic sequence is. Now we're going to learn something called a geometric sequence. So geometric sequence, oops. All geometric sequences is something like 2, 4, 8, 16, 32, and so on, right? What's the pattern here, guys?
Yeah.
So Ace, William said this, right? The nth term is just the n minus 1 term times 2. All we're doing is every single term we just multiply by 2 to get the next one, right? So instead of a common difference, which is what we had last time, right? Now we have a common ratio. Common ratio is just 4 over 2, 8 over 4, 16 over 8, right? In this case, it's 2. So we call the common ratio R. That's just whatever we multiply by every single time. Yes.
Here R is 2.
So in this case, R is 2, yes. So for when we add stuff, right, this is our formula. So what do you think our formula should be when we multiply by the common ratio? It's going to be something similar to this, right? So if we have n terms, in terms of the first term, how many times should we multiply by this common ratio?
Times d minus 1.
Times, no, it's not d anymore.
It's
These
R.
are common difference, that's r. So how many times should we multiply by r?
Minus
N minus 1. Right? So this is our formula. Let me erase this so you don't get confused. And this is our formula for the nth term of a geometric sequence, right? Very similar to the arithmetic, except we're just multiplying, right? And then make sure you guys, I think you guys are good with this, right? Once we get the first time, we just, instead of multiplying it by n times, you have to multiply by n minus 1 times. Yeah? Okay.
Is there no like implicit formula?
Well, this is the
Okay.
implicit, the recursive formula, right? This is just n term equals the previous times 2. Okay? So you guys seem like this all makes sense to you. That's great. So now let's find the 8th term. Eighth. I'm assuming you're gonna need a. Oh, you brought one? Okay. Here.
I have one.
Have you guys gotten what R is yet?
Almost.
Kristen has. William? No. No. Kristen, what did you get for R?
3.
Good. So Anish, William, figure out how to get 3 for R.
Does like the formula to find the common ratio stay the same?
Oh, look, this is the same concept as the previous, right? This does not have to be the first term. You can.
Yeah.
Kristen, what did you get for your answer?
8,748.
Good. Perfect. You are now on break, Kristen. Feel free to get food, chill. So how did it go? I thought they didn't deliver mails.
Since it's Saturday,
Yes,
why not in which service?
is the mail service. So it wasn't like UPS or anything. That's kind of weird.
Oh,
I'm allowed to like redefine these as like the first.
Yes, but did you get R yet?
No.
I'm messing up.
All right. So
If I look at it, I get how to get.
okay. So how many times do we multiply by R?
What's the
to get
power
from
of?
here to here?
What's the power of?
How many times do we multiply by R to get from here to there?
How many times?
Yeah.
3.
No.
Or 2.
2.
Yeah.
Right?
Sorry.
5 minus 3.
Yeah.
Kristen did something smart. Was what she did was this is the 3rd term, right? So this is the 4th term, and this is the 5th term. So you can kind of look at it. You gotta do it twice, right? Or you can just count on your fingers. That's something like I do a lot, right? 3 to 4 and 4 to 5. That's 2. So what's R gonna be?
36 cubed.
No. Okay, so 36 times R gets you to some number. This number times R gets you to 324.
So 36 times r squared is 324.
Right. So 36 times R squared equals to 324. So what's R?
Square root of 324 over 36.
Okay.
Okay, think about it.
Okay. So what's that? William, did you know how to get R?
I'm assuming that's
Yeah, I just read the formula wrong. So I thought it was R times and I just went.
If you know where the formula comes from, there's no reason you should
Yeah.
be doing that.
yeah, it's 3.
I'm smart.
So R is equal to 3, right? All right.
Okay.
So then how do we get 8?
A equals 4 times, well, A1 times 4. Or
8,
like,
so
sub
A
8
is
equals what?
Oh, A,
Let's just use
sorry.
in terms of A sub 5
In terms of a
times what?
R to the third.
times
R,
yeah,
which is 3.
Yeah.
How many times?
how?
5 to 6, 6 to 7, 7 to 8.
yeah,
So
so
3.
Yeah.
And then we just solve.
Fine.
Okay. Again, the easiest mistake is always to get this wrong, or to get like that wrong. How many times you multiply by R?
Or do I did.
So either you can write out like what Christian did, you write it out on the paper, or you do what I do and you count on your fingers. Either way works.
I get 8, 7, 4.
Yeah. Wait, 8, 7, 4. Yeah, that's right.
Yeah.
That's right. Good. All right, you're on break.